Cool. Good afternoon, everybody. Can everyone hear me? I can hear myself echoing, so that's a good sign. So Alice and I are here because we'd like to talk to you today about our experiences in investigating interesting use cases, really valuable use cases for AR. It's all about trying to figure out what AR is actually good for. So we're from a company, Cambridge Consultants, as you've just heard, and customers come to us with business problems, and we look for deep tech solutions to those problems to give them a real competitive advantage. In between our client projects, we flip this process. So we do internal projects where we take an emerging technology like AR and investigate all the possible ways it could bring business value. And Alice and I have been working recently on an internal project for the last year or so, trying to build some interesting demos to show clients and get people excited about this work. So I'm just going to hand over to Alice now for her to introduce herself and explain what drew her to this project.
Thank you, Matt. Can you hear me as well? Yeah. So as a designer, I saw AR as this futuristic interface that could really take interactions to the next level. It offers us the incredible opportunity to blend the physical with the digital world, and having a UX perspective that's grounded in user research, solving a real need, is really important not to lose sight of. If you have a UX that's not natural and intuitive, then the whole experience falls apart. And if you have a bad experience, then you have a product that no one wants to use.
Thanks, Alice. I myself am a software developer. I'm sort of broadly full stack, but with an emphasis on the front end. And I was really drawn to this AR project because I wanted the opportunity to build interfaces that go beyond a two-dimensional screen. I'm also really excited about this ability to blur the boundary between physical and digital worlds in AR. It's also worth saying we wanted to do this talk together today as a UX designer and a software developer, because you really need both of these skill sets to build any product or service that is both technically feasible but also desirable and meets a real user need. So when we started off working on this project, we had a bunch of ideas for use cases that we could apply AR to. And we started to go through the details of these use cases and realized although some of them worked, most didn't, at least not without quite a lot of tweaking. I'll give you a couple of examples. Early on in this thing, I was looking around the office and I saw someone servicing a coffee vending machine, and I thought, wouldn't it be great if they could hold up their phone to the machine and see the information they needed in context around the machine? And then I thought about it a bit more and realized, well, no, it would be a lot easier if they could just take a picture of a QR code and browse the documentation at their leisure rather than having to hold their arm out in front of them. So another example, we work with we've been talking to a company that make these amazing 3D models of organs for use in surgery, for planning and during operations. And they built a demo to entice clients in based on an Apple Vision Pro, where you could rotate the models and prepare surgery. But they found when surgeons really use this for real, they switch very quickly to a 2D keyboard and mouse interface, because although it had a higher learning curve, they could become more productive using that interface. So sometimes AR just isn't the right interface. So we went through a lot of examples like this, and we sort of began to see common classes of use cases where AR really shone. And Alice is going to take us through some examples now.
Thank you, Matt. So one of the first examples where we really saw, if the slide changes.
It's not changing. Can someone change the slide? Oh, well.
No worries.
Can you advance the slide, if possible? I don't know why the clicker's not working.
Perfect. Thank you. So one of the first use cases where we really saw AR's value shine through was in locating objects in the physical environment. So the focus here is on navigating the environment and actually allowing users to find items or places. So this could be done, for example, by highlighting an object or by overlaying directions. And I'll talk you through some examples now. So picture a warehouse filled with parts and supplies. And AR could allow you to know exactly where an item is, even if it's hidden behind another object. So you no longer have to be scrolling through large databases, hunting aisle by aisle to find an object, or even visually scanning a warehouse with hundreds of objects in them. So you can see this scenario here, which is made by a company, Quinzo. And the real value that AR brings here is in actually removing the friction. You're allowing users to view this information in their environment, and so you're really minimizing the attention switch. You're no longer having to search between a phone and the real environment. You're combining the two, which is giving that extra value. Or it could be, for example, with wind turbine maintenance, where you're overlaying drone data to help a technician repair and locate damage. So it could also have additional information like what tasks need to be done and in what priority. But the key thing here is that users aren't overwhelmed with huge amounts of data being visible at once. It's really important to filter what's most relevant to them in that moment. Another use case where we found that AR was really important was in discovering information spatially. So this is about revealing relevant information based on the spatial context. So instead of finding an object, it's about overlaying data about it or about an object that you're already looking at. The focus here could be on learning about or understanding more about an object by connecting it with the spatially relevant information. So for tourism, for example, that could mean walking around Vienna and you see relevant facts or historic data that are anchored to specific parts of a building. So this is demonstrated in this concept video by Keiichi Matsuda. So this is an example where, obviously, for tourism, you really want to see the environment, and so the value that AR brings here is in the pass-through that it offers. Or it could be, for example, that you're walking around in a country where you don't understand the language and you want to have the translation on the go. So, for example, it could be signs like an underground sign. So this is obviously using the environment and the camera feed as the input. So the value that it brings here is in showing that information directly overlaid and in context. It offers us this richer, more immersive experience and can bring a deeper connection to our surroundings. The third one that I'll be talking you through is expressing commands spatially. So this is allowing users to give commands to devices or systems by using spatial interaction. So an example of this could be directing a robot or a drone, for example, to go to a particular location. You can imagine pointing and seeing a kind of projected curve to show you where it's going to go. And this could be really relevant in scenarios where maybe speed or context-aware interactions are important, and it might be better than searching through a coordination system. Or it could be a simpler example, it could be simpler like pointing to a monitor screen to share what's on your phone, where you're spatially linking the command with that object. So it brings a whole new level of intuitive interaction, it simplifies complex actions, and can make command execution as easy as pointing, which has clear accessibility benefits too. So another example could be like a scenario we're in today. We're in a conference, there might be someone who has a question, and we could gesture to that person, and the whole audience could only hear them speak. We could even see subtitles, or we could adjust the mic volume. And obviously, from a UX perspective, this is hugely beneficial. You no longer have someone either running to the mic or someone holding it, coming to them. And so you're you're closer to the physical system. It's also allowing for more subtle micro movements and interactions to communicate our intentions. We're allowing ourselves to interact with a digital system in a natural way like we would do with a physical one. And so the fourth use case where we felt like AR was particularly important is the actual interaction with reality. So quite often we might want to see what a virtual object looks like in the real world and in context. So coupling it with the real environment creates a whole new level of meaning, and AR can make this particularly realistic. So an example could be IKEA Place, where you are maybe thinking of buying a new bit of furniture, like a desk chair. You want to see what it looks like in your home, see if it fits in with the decor. And so ultimately, this improves the decision-making confidence before buying something, and it unlocks a new level of interactivity and visualization. Or it could be a more playful or therapeutic application, like this one by a company called Animorph, where they're encouraging children to move around a hospital, which is linked to improved mood and cognitive function. It's particularly delightful seeing an animal move around in a jungle theme that's really interacting with their real environment. So a powerful tool that AR uses to achieve this is occlusion. It's allowing a digital object to sit behind a real one, giving us this real 3D kind of effect. Without occlusion, the digital asset would simply lay on top and it would feel much more flat. We can also add levels of realism by having realistic lighting and shadow. It can even respect the rules of physics with boundaries, for example, like walls, or having the tiger fall down to respect the rules of gravity when it jumps up. So these digital interactions are really simulating the physical ones, and they're adding that extra value that 2D screens just can't offer us. It's particularly important when we need to create engaging and motivational environments which might require emotional support, or maybe an element of delight is important. So I'll pass you over to Matt now, who will talk you through some maybe less commonly seen, but extremely interesting and complex scenarios that we came across throughout our work.
Thanks, Alice. So yes, so you've seen some fairly general, widely applicable use cases now for AR. We wanted to take you through 3 example applications of AR that use a lot of these use cases, but which we don't see very often at the moment, predominantly because they are technically very challenging. So the first one I wanted to talk about was digital physical bridging, and this is really what got me into AR a long time ago. So this video here is from 2008 from Microsoft, and it's showing these users interacting with the digital aspects of these physical objects, in this case Zune music players. So that really shows how old it is. And I think it's a really natural, quite magical way to interact, and you're seeing the display of information spatially, as Alice was talking about, and also the expressing of commands spatially there. We built a demo to try and exemplify this digital physical bridging, and there's a video of it here. This is done on a MetaQuest Pro, and so we have indicators floating above smart objects, so you know what objects around you are smart, and through gesture you can interact with these smart objects and express your commands spatially. So that first one there is a smart plant pot that tells you the plant needs watering or not, and other information. But you don't just have to see information, you can also express your commands spatially. So there's a smart lamp there, and you can turn the smart lamp on, and you can see it really turns on there, and change its color or its brightness. So this is a fairly trivial example. I don't think many people are going to buy a headset to switch their lights on and off, but you can imagine in a factory setting, pointing at a machine to get more information, or to deactivate it if it's malfunctioning. All sorts of applications in digital physical bridging. It's technically very challenging for a couple of reasons, though. One, you do need to know in a real-life application where your objects are that you're interacting with, so you need accurate positioning. And you also need interoperability between hardware devices and your AR application. At the moment, a lot of IoT devices, they're in their walled gardens. It's very difficult to interoperate them. The second really quite magical application we wanted to talk about today for AR is seeing the unseen. So here's an example from a Medivis surgical AR where you can literally see inside a patient's skull. So this is overlaying MRI imagery over a real patient. There are a couple of types of data I think you might want to visualize like this. One is static data that you know in advance and is just about placing it in space like this, although of course the challenge there is accurately placing it in space. And the second type of data is real-time data from sensors, for example. So flow rate meters in gas pipes under the floor, you want to be able to visualize the flow of gas. That brings up problems, again, of interoperability between hardware, software over a network. The third example of a really interesting application of AR we want to talk about was remote collaboration. So it's very common across a whole bunch of industries that you have a worker doing a complex task and they get stuck and they need to call in the help of an expert. And so rather than fly an expert in, nowadays you can use telepresence to have a video call with them perhaps, and they can be in more places at once. Here's a product that uses AR to augment that, allowing the remote expert to annotate the scene that the on-site worker sees, allowing them to kind of show rather than tell. This is an existing product by Vuforia. we really love this concept of remote collaboration, and we had clients that were very interested in this, and we wanted to build a demo that took this to the next level in terms of immersion. So we built a demo where one user is wearing an AR headset, Apple Vision Pro in our case, and the other user, the remote expert, doesn't just see a screen recording, they see they are immersed in the 3D scene as if they're alongside the actual worker. So the person on the left here is the actual worker trying to perform a complex task, and they're scanning the scene with the Apple Vision Pro scene understanding capability. And then that scene, that mesh, is sent over to the user on the right-hand side wearing a VR headset, and they are then placed inside the scene alongside a very, at the moment, a very crude avatar of the on-site user here. This is obviously a very early work-in-progress demo, by the way. But they can pick up objects from the scene, like this screwdriver, and they can show the user how to perform an action. And then the on-site user on the left sees that screwdriver rendered exactly in the scene where the remote expert intended it to be placed. And so we're developing this demo to allow more complicated tasks. This just creates a real true sense of presence, and I think this could be really exciting in the coming years. The big limitation at the moment, as you can see from the pictures, is the scene reconstruction. So this isn't probably good enough for a production system. But there are technologies that we'll talk about in a bit that can improve this situation in the future. So I'm going to hand back to Alice to talk about where the future's heading.
Thank you, Matt. So I think it's really important to see where we're looking to go in the future. And from my point of view, which is maybe more of a UX design focus, is I really see it going towards a truly responsive UI where we're actually integrating artificial intelligence. So for example, we could have dynamic systems where the user interface is responding to the user's goals, behaviors, mood, and even the context that they're in. So AR now becomes the input for AI using that camera feed. So the whole "where did I leave my bag" can now use that. It's also quite important to look at design systems, and so we can expect it to become a little bit more established. As there are more users interacting with mixed reality, we'll gain more insights from that. And as designers, we can use this to create a really solid foundation to base our design concepts off of. Accessibility is also important not to lose sight of. So we have the typical brightness, contrast, size of things, but even broader accessibility questions like the heaviness and bulkiness of the headsets, motion sickness, which is a real problem and still exists, and even price accessibility. And then the final thing that I think is really important to touch on is as we move to more gesture-based controls, it's really interesting to look into haptics and how we can allow users to have that extra immersion. So for example, receiving mid-air feedback, like feeling the texture of a material or even the temperature, to give us the impression that we're really holding something when nothing's actually there. So as I mentioned, this can take immersion to the next level, and I think all of these things are really interesting and really excited to see where they go.
Thanks, Alice. So I just wanted to highlight from a technical side of things, from the sort of developer side of things, 4 areas that I'm really excited to see progressing in the coming years. So the first one here, object and scene capture, is quite specific to that remote collaboration example we talked about. Capturing a scene and reproducing it in 3D is a hard problem. But we saw the talk this morning from Niantic about mentioning Gaussian splats. There's also NeRFs, neural radiance fields, really exciting developments in computer graphics that allow us to capture 3D scenes with a relatively small amount of information and create photorealistic copies. So that's very exciting to see. A really key problem in all of the AR applications we've seen is positioning, is trying to locate objects in space. A lot of our use cases depend on that. We saw a talk this morning from Niantic about their visual positioning system. And this is also a sort of technology involved in other products like Google Maps. You can do this, getting your position from what your camera can see. But there are other hardware solutions, Bluetooth direction finding, I believe it's called, allowing you to position yourself inside in indoor environments. And I really hope these kind of solutions become more ubiquitous as we start using AR more and more and can support these kind of applications. We've seen the importance of interoperability in a lot of these applications. This is a hard problem. There are incentives set up that companies build in their walled gardens. But I'm quite encouraged by the success recently of Matter finally sort of starting to gain some traction as a protocol to allow different consumer IoT devices in your home to talk to each other. So that's promising. And finally, obviously, the biggest hurdle to widespread AR adoption is headsets, is the hardware we use. So it was great to see the Orion prototype demo showing what could be possible in the coming, well, is definitely possible and will hopefully be coming down the pipe in the coming years. So that'll be really exciting. And I think once we have that kind of lightweight, high battery life, comfortable hardware, a lot of the objections to AR fall away that we've been talking about. So to summarize, AR is not just another screen. It is a brand new way of interacting with your environment. To really unlock its potential, though, we need to think critically about the unique value it can provide and whether you're meeting a real need. We have to keep pushing the technical boundaries to enable these experiences, but the future of AR will be shaped by the collaboration between designers and developers, building things that users actually want. Thank you very much.
If anybody has any questions about AR for enterprise or for specific challenges that you and your team are confronting, we're opening the floor for questions. Don't be shy. Okay. Oh, here we have got one. I'm running over.
Thank you very much. I'm curious, you showed a real breadth of really interesting use cases, but how far is the client work that you're doing, the problems clients are bringing to you, how far is that from the more kind of proactive stuff that you're doing? Do they meet in the middle, or are you doing a much more conventional bread and butter stuff?
Yeah, so Cambridge Consultants is a sort of wide, it's an engineering company across a whole bunch of disciplines, and AR is not a core part of our business at the moment, but this is quite a forward-looking project to try and excite clients about the possibilities of it. But our clients are asking us about it. We are working with automotive clients at the moment to allow them to augment their car mechanics ability to do their work quickly, and with support not just from remote experts but also from AI, to allow them to not need so much training to be able to sort of get help from AI in a way they don't have to keep running back to a computer, so using a headset for that. That's a very exciting opportunity. And we've been talking to an aerospace client that are interested in this very much for the remote collaboration example we saw. So there's a lot of interest there. And we have talked to clients that are using headsets for things like picking and placing in warehouses and things like that. So yeah.
Distance collaboration and enterprise use cases are many, and I think that this is yet another example of the fact that this is a space where a lot of businesses are seeking to come in and help their clients come up with solutions. We tend to see this over the past, say, 10 years in upstream manufacturing and also operations, but now we're also seeing it along the entire value chain. So well done. Thank you so much for such helpful illustrations. Alice, Matthew, thank you so much. Please, a round of applause for our guests.
Thank you very much.
We're going to take another 3 minutes until our next speaker, so if you need to stretch your legs or have a question for our guests, please take a moment.